Chapter 1, Section 7 is differentiation techniques. This time we're going to talk about the chain rule. The extended power rule, which we're also going to call the chain rule, is used when we have a multi-term function being raised to a power. So notice how this is written. I have g of x, which would be a multi-term function, and it's being raised to some value k, which is a member of the real numbers. When I go to do the derivative of this, I'm going to think of something being raised to the k power as an outside function, and whatever's being raised, this multi-term function, will be the inside function. So derivative is going to be the derivative of the outside, which would be the power times the function raised to the k minus 1 power, times the derivative of that multi-term inside function. So the derivative of the outside times the derivative of the inside, and we'll be good to go. So find the derivative of y is equal to 8 minus x raised to the 100 power. We're going to think of the outside function as something being raised to the 100 power, and the inside function as 8 minus x, whatever the multi-term function on the inside is. So when we do the derivative of this, dy dx, it's the derivative of the outside, so 100 times whatever's in the parentheses, being raised to the 100 minus 1 will be 99th power, times the derivative of whatever's in the inside the parentheses, so the inside is 8 minus x, which will be negative 1, and then when we simplify this, negative 1 times 100 will be negative 100 times 8 minus x to the 99th power. For the second example, our outside function is going to be something being raised to the 20th power, and the inside function is going to be 5x plus 2. So when we do the derivative, dy dx will be equal to the derivative of the outside, so 20 times whatever's in the inside, 5x plus 2 raised to the 20th minus 1 power, so 19, times the derivative of the inside function, derivative of 5x plus 2 is 5. And when we simplify this, 20 times 5 is 100 times 5x plus 2 to the 19th power. This is the chain rule. We're going to use this extended power rule or chain rule in conjunction with products, quotients, addition or subtraction rules. So let's consider the derivative of the square root of 1 plus 8x. Well, you know that we can't split this into a sum of two separate radicals because it's a sum. You can only do that with products. So 1 plus 8x is going to be the inside function being raised to a power because we have to change this into an exponent. So 1 plus 8x, the square root as a power is the 1/2 power. So now our outside function is going to be something to the 1/2 power, and our inside function will be 1 plus 8x. So when we go to do the derivative, dy dx will be equal to derivative of the outside, so 1/2 times 1 plus 8x to the 1/2 minus 1 is negative 1/2, times the derivative of the inside, which is 8. We simplify this, 1/2 times 8 is 4, excuse me, and then negative 1/2 goes into the denominator, and if we write it in radical form,